start again. So, and then let's erase this. Again, erase out. Then let's use our hands to move these back. And then we'll do something else here. So we'll move that back. Then we'll erase these. And we'll look at numbers or exponents. So here's an exponent, x. Okay, if I told you there are this many x's, x squared that is, how many x squares are right here? 1, 2, 3, 4. There's 4 x squares, right? So we say 4 of those x squared. There's 4 of them, okay? So that's what 4x squared means. There's 4. We're describing them. If we were to add them together, let's say if I added, let's say if I added that 4x squared. Oops. I'm gonna erase this. Okay. Let's say I move this over here. Okay. I have 3x squared in there. So I have, if I add those two together, you of course would tell me, just like the apple, how many do we have here? 1, 2, 3, 4, 5, 6, 7. We have 7 x squares. Okay? And of course we can look at it like this. Instead of writing a bunch of x's like that, we can think in our head and say 4, let's use green here, 4 x squared, and then over here we have plus 3 x squared, and that would give us, of course, 7 x squared. That's what we mean by adding exponents. And notice that the base, the important point is not the base, but the x squared is the same. Okay, it's the same thing. You can add things that are the same. It would not make sense to add. You can't. So basically, you can't say. Let's say, for example, if I added 10, 2 of these and 2 of these, that doesn't make sense, because what happens is you get, if you add those two together, you get this is 2 times 10 to the third, and there's plus 2 of those x squared, right? 1, 2, 2. And you can't do anything. That's it. That's all you can do with that. Okay? All right, so let's erase that. Now it's just to erase. So we can do this. Oop, we don't want the whole thing. Of course, I don't know why it does that. There we go. Okay. Let's put the x back in this location here. And if we look at 10 to the third, the same idea here. How many 10 to the thirds do we have right here? If I put here, we have 1, 2, 3, 4. 4 of those. So we say 4, 10 to the third, like that. That's how we describe that. So if we were to add, let's say we wanted to add, let me use the eraser here. Back to the hand. If I wanted to add 3 of these 10s and those like that, I'd say 3. There's 3 10s to the thirds, and we use red here. 10 to the third, and plus 2 times 10 to the third, okay? Because there's 2 of these. And of course, how many do we get? We get 5, because 3 tends to, see, 1, 2, 3. 1, 2, 3, 4, 5. 3 plus 2 is 5. And then we just bring the times 10 to the third, okay? See, the identity here is 10 to the third. You can't have, so x to the third plus x to the second does not get you anything. It does not equal x to the what? Third? Or is it 2x to the second? We don't know. We can't do that. Those are two different things, okay? Hopefully you can see that. And then I think that's it. The other one's the same idea there. If you erase, let's see, erase that. Let's see if I erase this. And if you do, if you move this around here, how many do we have of these things? We have 4 of these things. So we can say 4x plus 2, like that, okay? And if we want to add 2 of those things over there, we say plus 2x plus 2. That's going to give us 6x plus 2, okay? So to sum it up, in adding exponents, the identity must be the same. You can subtract it too as well if you want. It still works for subtraction like regular numbers. So we have to write the so to sum it up, you can only add or subtract if the identity is the same. 2x squared plus 3x to the third cannot be added because the identity is not the same, okay? But you can add 2 plus 3x to the second. The identity is the same, x squared. So you get 5x squared. See, just add like regular numbers and then carry the identity, which is x squared, along with it. All right, and that's it for adding exponents.